So this is a video to go over acid-base neutralization in case you weren't in class the day that we were talking about this. So a few things to remember is that whenever you are reacting an acid to a base, that is going to create two very specific products. You're going to have water, and you're also going to make a salt. So for these practice problems, and we're only going to go over the first four, what you're going to do is you're going to balance the reactions, just as a really good review over doing that, since we are coming up on the semester exams. But you're going to balance them, or if it's just words, then you're going to write out the formulas and then balance them. You're going to circle the formula of the salt that is formed, and remember, this is the product that isn't water. So, pretty easy to tell that's which one is water, which one is salt. And it's only on the product side. You're going to identify if the acid is strong or weak, and you can use the notes from page 5 of the packet for the strong acids and bases. Anything that's not strong automatically is weak. So you have to identify the acid, and for the acid, always starts with H. Let's see, it can also just be listed as acid in its name. For the base, it always, at least for these that we're using, always ends in OH. So, easy way to tell the difference between acids and bases. Alright, and then based on whether you have a strong or weak acid or a strong or weak base, that's going to decide what type of salt you end up with. And for the rules behind that, if you've got a strong acid reacting with a strong base, the salt is going to be neutral. Now, if you've got something that is acidic, that means your strong acid is overpowering the weak base that it's reacting with. And so then that's going to make the salt acidic. If it is a basic salt, that means that your strong base is influencing your salt, overpowering the weak acid to make the salt basic. And then if you need more info, that's when you have a weak acid reacting with a weak base. Okay, so those are the basics. Now let's actually get to doing these bullet points. So for the first problem, here you've got 2 Na, here you've got 1. So whenever you're balancing, you always have to use coefficients in front, so that's going to be a 2 in front of that. So now we've got 2 of our Nas. Also, side note, whenever you've got polyatomic ions that do not change before and after, you can just count them as one item. So we have 1 SO4 on both sides, so that's balanced. Now with this 2 in front, we've got 2 Na, so that part's balanced. But that 2 is going to influence the O and the H after it in this compound. So this gives us 2 oxygens and 2 hydrogens here, but we also have 2 hydrogens here. So in order for us to have 4 hydrogens and 2 oxygens on both sides, I have to put a 2 in front of the water. And that's going to make the entire thing balanced. So, first bullet point, done. Second thing, we have to figure out which one is the salt. So we already know we're going to have an acid reacting with the base as our reactants. So our product that is not water is this. So that is the salt. Then we got to figure out if this acid, and I know it's acid because it's got an H in front, if that acid is strong or weak. Since this has more than 2 elements in the acid, we have to look at how many oxygens and hydrogens there are. Since we've got 4 oxygens and 2 hydrogens, if we do that little calculation, that gives us 2. As long as that number is 2 or bigger, that means that this is a strong acid. Alright, for this base, and I know it's a base because it has OH, this base has an element from group 1 that makes it a strong base. And just like we said earlier, if you have a strong acid reacting with a strong base, that means the salt is neutral. So that's how you do the problems, but let's go ahead and do another practice using problem number 2. So, here we've got all of these compounds. Something to notice is that this ion and this ion are the same. It's just that we have this in parentheses with the 3 on the outside to say that we need 3 of these ions. But we only have 1 over here. So best way to balance out 3 when you have 1 is to multiply it times 3. My ALs are the same number, 1 and 1, but this gives me 3 H's. This 3 on the outside of the OH distributes or multiplies in with what's in the parentheses. So we've got 3 oxygens, we've got 3 hydrogens here, and 3 hydrogens here, to give us a total of 6. So the only way that we can get 6 hydrogens and 3 oxygens from this water is if we use a coefficient of 3. So there, it's balanced. For the salt, that is the product that is not water, which is this, so I'm going to circle that. That is my salt. Now, looking at our list of strong acids and bases. This is not a strong acid. If we do the calculation 2 minus 1, that gives us 1, which means it is weak. Another reason why it's weak is because it's got carbon in it. Now for our base, if it's aluminum oxide is not listed as a strong base, so it has to be weak. And anytime you have weak with weak, that means that we're going to need more info. So there, done. Okay, moving on. Okay, so next we've got lithium hydroxide plus phosphoric acid makes lithium phosphate and water. So lithium has the symbol Li, and it has a charge of +1. Hydroxide is OH, since it's a polyatomic ion, with a -1 charge. When you crisscross these two charges, you're going to end up with 1 and 1, and we're lazy scientists, we don't really write 1s. So we can just write this as LiOH. And that's it. Then for phosphoric acid, all acids start off with hydrogen ions, which has a +1 charge. Phosphoric was named after phosphate, which is PO4, with a -3 charge. When we crisscross this, the 3 is going to become the subscript for the H. The 1 becomes the subscript for PO4, but remember, we don't write 1s. So we can actually write it like this, H3PO4. To make lithium phosphate, lithium again has a +1 charge. Phosphate is PO4 with a -3. We're crossing the 3 down to here, so it becomes the subscript for Li. And then PO4 stays as is. We don't need to write the subscript of 1 next to PO4. It doesn't need parentheses around it. And then last, water, H2O. Now we got a balance. We're going to start with the Li's because PO4, we've just got 1 ion on each side, so we're good. For Li, this has 3, this has 1. So using a coefficient of 3 balances out the Li's. But now we've got 3 times 1 is 3 oxygens, 3 times 1 is 3 hydrogens, plus these 3 hydrogens gives us a total of 6. So the only way we can get 6 hydrogens and 3 oxygens from this is if we use the coefficient of 3. So now it's balanced. And then also, out of the 2 products, this one is not water, so that has to be our salt. So next we got to figure out if the acid is strong or weak. If we do 4 minus 3, that's just 1, so that's got to be a weak acid. LiOH, on the other hand, Li comes from group 1, and that makes it a strong base. Whenever we have a strong base combining with a weak acid, that makes it basic. So our salt is basic. Alright, last problem we're going to be doing for this video is this one, number 4. Hydrochloric acid. Anytime you start off with hydro, that means it's just going to be H and the element, Cl. For HCl, we had a +1 charge and a -1 charge, so when they crisscross, they just cancel. So it's just HCl for the formula. Now, this Roman numeral tells us that copper has a +2 charge, because the Roman numeral tells you the charge for your transition metals. Hydroxide is just OH with a -1 charge. When you crisscross these two, copper is going to have a subscript of 1, but we don't write 1s, so don't worry about that. But copper is going to transfer this 2 to become the subscript of hydroxide. But hydroxide is its separate own ion. So we got to show that we're keeping the ion together. It's still hydroxide, but we've got 2 ions of it. So that's why it's in parentheses. For copper 2 chloride, copper +2 because of the Roman numeral. Chloride is chlorine with a -1 charge. When we crisscross, copper has a subscript of 1. We don't write 1s. And then chlorine gets this 2 transferred to become its subscript. And that cancels out the charges. And then we have water. So the product that's not water is this. This is our salt. Now for hydrochloric acid, it is listed as one of our strong 2-element acids, so strong. Copper hydroxide is not a strong base though. It is not in our list, so that's weak. And then that means that our strong acid is going to overpower our weak base, just like it says here. So this salt is going to be acidic. I hope that lesson helped. Let's see. Please make sure that you do understand how neutralization works, how it all comes out. And of course, if you have any questions, please do ask me either during class or tutorials. Have a great listening.